All right, guys, here's a quick lesson on electrical resistance. This will be the last in these first three lessons. You had one on current, one on voltage, and now here's one on electrical resistance. Electrical resistance is a measure of how much an electrical component opposes the flow of electric charges. By electrical component, that could be the conductors themselves, the wires, a resistor, a light bulb, whatever. So what happens is the electrons flow through the conductor. They do encounter with and collide with atoms of the conductor. And every time they collide, the electrons will lose a little bit of its energy and turn that energy into heat. This video here, I'm going to post it. It's a TVO video that will give you a good understanding of what resistance is. Mostly what I'm going to teach you is how to calculate resistance. So Ohm's law, named after Georgy Ohm, is the voltage across a resistor divided by the current is a constant, and that constant is the resistance. So it's V divided by I, R, V, and I. V, of course, is voltage measured in volts, I is current measured in amperes, and R is resistance. It's the only new variable here. And it is measured in ohms. And its symbol is this horseshoe sort of looking shape here, omega. So example number one, again, pause this video if you need to write things down, speed it up, slow it down, do whatever you got to do to get through this. Voltage drop of 2.5 volts was measured across a wire that had a current of 125 milliamps through it. Calculate the resistance. Piece of cake, V divided by I, which is 2.5 volts divided by 0.125 amps. Make a mental note of the conversion I made there from milliamps to amps. And I will type that in right now. 2.5 divided by 0.125 equals 20 ohms. Not my best ohm symbol, but it'll do. That's about the difficulty level you're looking at for this. It's something that's covered in grade 9. I cover it in pretty much the same way, same difficulty level with grade 9s. The resistance of a motor is said to have that much resistance, 230 ohms. Hey, there's a good shot of the ohm symbol. If the current is 1.2 amps, determine the voltage. Just arrange the formula to solve for voltage. It's I times R, 1.2 amps times 230 ohms. Ooh, that's an ugly ohm symbol. Let me clean it up. That's a little better. 1.2 times 230 is 276. I'll round it to two digits and say it's 280 ohms. Just got to play around with this formula. All right. So if we were to, you've got two graphs here, okay? Both of them are voltage versus current. Voltage goes on the y-axis, current goes on the x-axis in both cases. So you have two types of components in electrical circuits, ones that follow Ohm's law and ones that don't follow Ohm's law. There will be an assessment question on this, so definitely pay special attention to this slide, all right? So for ohmic resistors, or any ohmic component, that means they follow Ohm's law, which means you get a straight line when you graph volts versus amps. So if we were in the classroom, what I would have you guys do is hook up a resistor to a power supply and just nudge the voltage up over time. And if the current increases at the same rate or in this linear fashion, then you'd say it follows Ohm's law. It's an ohmic resistor. If something doesn't follow Ohm's law, then it curves. So non-ohmic resistors have an increase in resistance when they get hot. Heat usually equals more resistance. So the current slows down and yeah, it takes more potential difference to get that current going. So important slide here. Just make sure you make note of it. There will definitely be a test question on that and whether or not it follows Ohm's law. Also, if I go back here again, the slope of the line is equal to the resistance. So what happens with the slope in the curve? Well, the slope is not constant, it is increasing. If we were to draw a tangent line there and a tangent line here, you'd say that you get a higher slope at the ends, and that shows you that increased resistance. The slope is equal to the resistance. All right. Factors that affect the resistance. First thing is the type of material. Some materials just happen to be better conductors. The better the conductor, the lower the electrical resistance. Copper has a really low resistance. Second thing is the length. Longer the wire, the greater the resistance. It's going to take more. The voltage is kind of like the force in some explanations. So it's like the push. So the longer the wire, the more the resistance in the wire. Cross-sectional area. As the area of the wire increases, the resistance decreases. Again, if you think of it in terms of force, a fatter wire is easier to push the electrons through than a skinnier wire, because the skinnier wire's got less area, less room for you to push electrons through. And then finally, we've already discussed this, the temperature. As the temperature of the wire increases, the resistance increases. Hopefully that makes good sense. Am I going to teach you how to read resistors? No, I'm not going to do that part. I got to make some cuts somewhere. So I want you to make sure you know the 4 factors that affect resistance. You're going to have to recite those in the assignment anyways. The other thing you're going to have to do in the assignment, if I go back here, there is no graphing in the assignment. Just I want you to make sure you come back to this slide when you're thinking about an assessment question, which won't be for a couple more weeks, but just this is an important slide right here, and you're going to have to do some calculations. As a matter of fact, since this is a pretty short note, why don't I go into the assignment and just show you kind of what you're up against, guys. So if I go here and I go to what's coming in this post on resistance, so it says watch the lesson. You're doing that right now, presumably. Watch the TVO video. That's that 9-minute video there, Electricity 101 on resistance. And then it says complete and submit the assignment. So that's this right here. And it's pretty short. I mean, this is, you're looking at about, if you know what you're doing, it's about 10 or 15 minutes tops of work. State Ohm's law, state the equation, rearrange the equation, and then solve 1, 2, 3, 4 problems. And then finally list the 4 factors that affect their resistance in a conductor. So that was that last slide that I was on. Just recite those 4 things that affect the resistance and how they affect it. And that's all I want you guys to do for the rest of this week. Let me know if you could use any help on any of this stuff, and I'd be happy to help you. If not, you will hear from me again in a few days, and we'll be looking at circuits and Kirchhoff's rules, voltage and current and parallel and series and all that good stuff. Stuff, again, that you have touched on in grade 9 science. All right, guys, I think that's it for me. Email if you have any problems.